Hello there, I'm Thomas Hatsios, I'm an American pilot flying the Boeing 787-995 from Zurich International Airport. We're going to be overflying Zurich, Switzerland, Germany. Then coming back to the Zurich International Airport, runway 1449, let's localize our landing. So now in the cockpit for the pre-takeoff preparation of the quality wings, Boeing 787-900 and Microsoft Flight Simulator X. I'm going to start showing you the cockpit instruments, display and functions of the Boeing 787-900 jet aircraft. I'm going to start with the primary flight display. That displays the airspeed indicator, the airspeed selected from the autopilot and flight director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the barometric pressure of the outside atmosphere, the vertical rate of climb descent of the aircraft in tens, hundreds and thousands feet per minute, all the steepness of the trigonometric angles increase and incline and descent. We have also the attitude indicator with the pitch ladder decrease and the bank angle and decrease the artificial horizon. The flight mode annunciator with the autopilot and the auto-throttle, later on vertical navigation modes, and also the Lszh localizer in the navigation display. You can see the horizontal localizer and the vertical glide slope. We have the threshold antennas of the Lszh localizer that transmit radio frequency from the runways we use for takeoff and for landing, so we can align the aircraft with the magnetic North Pole heading. So we have the runway 14 in Zurich International Airport. In Switzerland, we're going to be aligned with the magnetic North Pole heading of 136 degrees for this runway and its own radio frequency. For the Lszh, for the instrument landing system, transmitter and receiver, so we have the onboard aircraft receiver antennas, and we can align the aircraft in the air when we approach for landing with the horizontal localizer and vertical glide slope. We have also the radio altitude above the ground level that can display up to 2,500 feet, the edge side, the horizontal situation indicator. We can see the magnetic heading and track, and also the integrated flight plan display. You can see the purple magenta lines of the flight plan. So we have the waypoints, the stars. We can enter, select the waypoints from the flight management computer. So we have also the navigation display. The navigation display that displays the horizontal and vertical profile of the aircraft as it flies. You can see the terrain and weather reflections from the weather radar. You can see the terrain displayed with red, amber, and green indication. Also the lakes, the rivers, and the sea with blue. So we have also you can see the horizontal and vertical of the terrain around you. Also the distance is located. You can see also the magnetic North Pole, the graphic North Pole, the magnetic variation depending on where we are in the world. We have the terrain map with the airports. You can see the airport's four-letter account name for each airport. So we have our own airport right now that we are located on the Zurich International Airport, Lszh in Switzerland. So we have also the navigation aids, board stations, ADFs, the waypoints. The waypoints which are horizontal and vertical navigation fixes and altitude and airspeed constraints. The aircraft is gonna have to fly through some waypoints as we fly. So we select the waypoints from the flight management computer. Are gonna be creating a flight plan later. You will see the way how. We have also the GPS position of the aircraft, the latitude and the longitude. So we have also other aircraft that fly around our own aircraft. You can see them displayed from the transporter, the DSP and AC transmitter, receiver, transmitter of frequency to other aircraft, and the air traffic control and receives from other aircraft. You can display, you can make calculations using its computer and display the other aircraft where they are located, the distance from the aircraft and bearing, also the altitude difference from our aircraft, how many hundreds and thousands feet are above or below our aircraft, where the climb or descent with respect to our aircraft, and also you can make calculations about velocity closing in between our aircraft and the other aircraft. So we can calculate if we have an incoming collision. It will give us a warning from the TCAS system. The traffic collision advisory system. You can see the diamond shape of the other aircraft displayed in the navigation display. We have also I'm gonna show you also the flight controls of the aircraft. I'm gonna use the side stick here to control the Boeing 787 for climb descent, to use the control column the yoke of the Boeing 787, so we can climb in the sand. We use the pitch axis like this. We use the roll axis like this, longitudinal axis. The side stick can be Airbus left and right. Also the rudder pedals. So we have the rudder pedals also. I have it in the side stick. I can use the vertical rudder for making yawing turns, and also for the nose wheel steering we have the tiller interconnected in the aircraft. So we have other systems you're gonna see. The horizontal trim stabilizer over here. I have it in the side stick, so you can see this trim switch for the horizontal tail elevator stabilizer trim. So you can trim the horizontal tail of the aircraft like this, trim up and trim down. You can see displays elevator, trim left click down, right click up over here. As you can see, left click down, right click up. So you trim the elevator up, you pitch the nose of the aircraft up as you fly, and you trim the elevator down, you pitch the nose of the aircraft down as you fly. You have the autopilot disengage switch, the head-up display, the flap speeds over here. So you can see the control wheel, control column, and rudder pedals. Also you can see the thrust levers here I'm gonna use. You can see the auto throttle over here, disengage switch. This switch you press and you disengage the auto throttle. Takeoff, go around over here. Thrust reverse, you pull up when you land in the idle position. Also the flaps, I will show you one by one every switch. The alternate pitch trim you can see for the elevator. So we have the alternate, you can see elevator pitch trim up, and nose down. Again you trim with the alternate flight control computers channel over here. The nose of the aircraft as you fly, pitches up and pitches down, or the elevator trim up and trim down. So this is the meaning. Some aircraft have the whole stabilizer, horizontal stabilizer, not just the elevator trim. So we have also the parking brakes over here, the stabilizer trim cutoff switch for the auto trim system. You open up this guarded switch over here and disengage if you need the auto trim function. So this is in all Boeing 737, 747, 757, 767, and Boeing 777 and Boeing 787 aircraft. You open this red guarded switch from normal to cut off over here. If you have a failure that affects from the hydraulics, you have a failure of the hydraulic system over here that affects either you can see the hydraulic system, and it affects the flight control computers over here. You can see primary flight control computers in the auto position. This is fly-by-wire aircraft. So we have the flight control computers. We have also other air data computer, flight control service. So I will show you also these functions. So it will give us a failure from the auto trim function of the autopilot flight director system panel over here. You can see the autopilot flight director, autopilot engage, disengage over here, switch. You can see disengage like this. You pull the slider down, flight director on and off, auto throttle left and auto throttle left and right, on and off, engage, disengage. We have also LNAV, VNAV, climb continuous auto throttle, flight level change over here, FLCH, flight level change. You want to change flight level, the airspeed, nav commands, notes, heading, bank angle, I'll see you later, vertical rate of climb descent over here, and now the altitude, thousands of feet, barometric altitude selected. So we set the barometric altitude. You can see in the primary flight display the airspeed and the altitude are the same values, 200 and 10,000 feet. Also the heading, so we have 200 nautical miles over here. You see 200 displayed over here. In the primary flight display 10,000 feet over here. The airspeed indicated, the barometric altitude selected and also indicated. So also you can see the barometric altitude is displayed 29.92 inches of mercury over here. The radio also, and the heading. So we have the barometric altitude set by the barometric setting over here. You can change it. Right now it's 29.92 inches of mercury. You can increase or decrease. It will change the value of the barometric altitude depending on the airport, um, 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 as needed by every airport, and different time and day. So it depends on the weather. So we have inches of mercury or hectopascals. Right now I have it 39.92 inches of mercury or 1013 hectopascals. The minimums, radio, barrel set, the plan, map, menu, range over here, nautical miles, increase and decrease, weather radar, traffic and terrain. This is for the display over here control. We can change some settings, the range of the display. Also we have accept, cancel, reject some warnings here. We have the display of the warnings over here, the messages. We have also the display of the systems over here, systems, CDU, info, checklist, communications, navigation, display, ACAS, cancel. We can change, expand the map like in the right side. Right now I have the engines, so we can see the other systems that we have in the overhead panel over here, like the electric, hydraulic, fuel system, the pressurization, pressurizer, and flight controls. You can see these systems later in the display. Over here we have the engines right now displayed next to the navigation display and the primary flight display. So we have the airspeed indicated, the airspeed tape. You can see other information here. So we have the airspeed indicated, increases, no V-speeds not selected yet. Barometric altitude, vertical rate of climb descent of the aircraft, 10,000 feet per minute. So you see this needle moving up when we climb, like 500, 1000, 1500, 2000, 3000, 6000 feet per minute, or when we descend. Also we have the pizza digit 2.5, 5 over here, 7.5, 10, 12.5, 15, 17.5, 20 degrees for pitch up and pitch down as we fly. Also the bank roll of the aircraft. You can bank roll like 5, 10, 20, 30, 45 degrees, either left and right. Also the flight mode annunciator for the autopilot and auto throttle. These three we need maybe to run something. I'm not sure, to display the takeoff go run. It's not yet displayed for some reason. We need maybe to reset the flight director on and off over here. So you can see the flight director, the crossbars here. Also we have the Lszh later displayed, the primary flight display, the heading 360 degrees, ADF receiver left and right. The navigation display also here. You can see the terrain map. You can see the Switzerland, our own airport, the run we're gonna use, the VOR. Over here the airport and also the aircraft symbol and heading over here, magnetic north pole heading. In the map you can see the airport terrain elevation 4,000, 900, 016, 1,600, and the airports Germany and France over here. We can look even further, we'll see more airports like this. You can see more like in the France over here, and the Germany up here. So it's this way for Germany. It crosses some borders. We have the Switzerland down here. So you can see also the aircraft as we fly over here. We can see the aircraft symbol, and also this line is the distance above the ground. We have selected. Now we have the range distance, the horizontal 160 nautical miles. This map display here. So you can see how far above the ground we're gonna be flying, and also the terrain around you and below you. If we look closer now, we have set from the range here and on plan map over here 18 nautical miles. So we can see even closer. We'll show you later. We don't have the airport yet displayed. Because we need to select first the airport, the flight management computer over here. So you can see the setup that I have for my computer right now over here. The keyboard that I'm using, and the screen of my computer. So you can see the mouse pad I have here also to control the flight management computer over here. So this is the setup. So we have also, I will show you the outside view, talking about the flight controls over here. So I'll continue now with the engines indications. You can see we have from the FAREX, we have the landing gear now extended over here, down, up and down, see the display. The alternate gear, the lock override, the auto brakes for landing, set for landing, auto brake 1, 2, 3, 4 max, or rejected takeoff, RTO. The standby display, also the engines indications from the FAREX. You have the N1, which is the low speed starter and low pressure compressor and turbine of the turbofan, which is engine the left and the right. The takeoff limit 99.2%, green, red, yellow indications, limits never exceed over here. Exhaust gas temperature 447 degrees Celsius, and 2, which is a high speed starter and high pressure compressor and turbine of the turbofan with the engine. So we have the low speed starter low pressure compressor and turbine of the turbofan with the engine, and the high pressure compressor and turbine of the turbofan with the engine. Low speed starter and high speed starter and fuel flow per inch per 1000 kilograms 1000 pounds, oil pressure, oil temperature, oil quantity, and the vibration of the N2 stage of the engine. We have the outflow air also. It's applied usually from the 5th and the 9th stage of the outflow valves of the and from the engines, left and right. They have high pressure air, so they supply cabin pressurization. Here you can see cabin altitude right now 1400 feet, rate of climb descent, the outflow valves position over here. Outflow valves coming, rate of climb, differential pressures are about 43,000 feet. We're gonna be having a differential pressure of like 7.8 or 8 psi, and cabin altitude of like 6, 7 or 8,000 when we climb to 43,000 feet. You can see also the outflow valves for pressurized and depressurized the aircraft cabin. You can see also the gross weight for takeoff over here. 357.9 thousand pounds total fuel on board, fuel temperature -6, and saturated air temperature. So we have the cabin pressurization here set. The outflow valves over here. Auto position right now you can see we can use a manual. So we have the engine's pressurizer, also supplies the air conditioning, ventilation, oxygen regulation in the cockpit and the cabin. Also the hydraulic fluid tanks pressurization over here. We have pressurizer from the engines for the engine driving, also electric uh, and engine driving primary demand over here. We have the rammer turbine also, obviously some years later, and also the pressurizer supplies the wind and engine on the ice over here with the cabin pressurization and the hydraulic fluid tanks pressurization. So the hydraulics, when we move the side stick in the Airbus or the yoke in the Boeing, we move the flight controls around of the aircraft. We activate the hydraulic system, the actuators. So this is a fly-by-wire aircraft. It has a flight control computers on board to make calculations how much they will deflect the flight controls in the air when you move the side stick or the yoke in a commanded position or the rudder pedals. So also the hydraulic fluid for engine thrust reverse, landing gear extender retract, parking brakes, auto brake system, the nozzle string in the front nozzle over here, the tiller for the nozzle, and also the systems like speed brakes and flaps over here. We're gonna set the flaps later. You can see the flaps position. You can set how many degrees we need the flaps. You can see the flaps in transition right now, extend 30 degrees. Also the speed brakes, retract and extend. We have also the left and right engine, auto throttle disconnect. We have the fuel control, fuel flow valves, run and cut off over here, fuel control as you can see. And also the fire extinguishers for the left and right engine, pull out and switch, the transporter, the rudder trim, the VHF, high frequency communication for the air traffic control, high frequencies, satellite weather radar transporter, ILS localizer. Also we have the navigation radio, and this is radio and communication panel, communication radio also. So this is the flight management computer here, the screen. I will show you in a couple of minutes how to use it. The keyboard over here, alphanumeric keyboard, how to use the index and the mouse pad here. So this is the full cockpit setup. Before going into flight, I will show you now the outside view of the aircraft of the Boeing 787. I will show you the outside view, and I will talk to you about Newton's physics, aeronautical and aerospace engineering, and derive some principles we need to know for flying the aircraft, the Boeing 787-900. I will show you also the flight control system. So I will talk to you about the aerodynamics of the aircraft when we fly, what we need to know for the air transfer pilot's license and the commercial pilot license. So you will see now also I'm gonna use the flight control system. I'll have this Logitech Stream 3D side stick to control the flight controls of the Boeing 787. You will see how I'm using that to control the aircraft. So you can see here we have the side stick. I can climb and I can descend. I will show you now. We make the left and right, side stick left and right in the Airbus, control wheel left and right in the Boeing. So it's the same flight controls, also the rudder pedals, the tiller for the plan. I will show you now the outside. So you can see here we have the outside view of the aircraft of the Boeing 787. So you can see the wings of the aircraft, all the weight of the aircraft, how the aircraft fly. We have the surface area, the weight over the surface area. We have this creates the lift force that lifts the aircraft weight up into the air from the force produced from the airflow around the wings, differential pressure. So I'll talk to you about now. So we have the thrust vectors from the engines, the jet blast from the engines to move the aircraft forward, the propulsion system. You can see the cones, the exhaust cones from the engines, from the high pressure compressor and turbine, and the combustion jabber over here, also the bypass air here section. So we have also the low pressure compressor turbine in the front, and the front fans over here. We have also the fuel lines located over here from the left wing and the right wing tank that feed either engine. So we have 30% in the left and 30% in the right now loaded, and 10% the center tank. So this is the fuel loading right now. So we have also, you can see we have the mineral dynamic chord position, the Mach, which is 23% of the mineral dynamic chord over here. Where the maximum aerodynamic lift occurs in the forward wings is also the position where the center of pressure is moving back and forth when we fly. Also where the stall will begin in flight. The airflow becomes detached from the top surface of the wings for a given angle of attack and airspeed that changes. So the airflow becomes detached from the top surface of the wings, and the aircraft might gonna start falling. So we need to avoid the stall speed. In the air we pull the side stick or yoke down and advance the thrust levers to increase the airspeed and decrease the altitude, the pitch altitude of the aircraft. So you need to monitor the airspeed tape over here as you fly all the time. You see the airspeed indicated, then you have the stall speed to be displayed with an amber and a red indication below the airspeed in the airspeed tape over here. So this is the stall. You can see later in flight. So we have a few more things to see. We have also the mineral dynamic chord. We have, as I told you, the fuel, the center left and right wing fuel tank. So we have the center of gravity is located where the mineral dynamic chord is in the forward wings over here. So is this section, the forward wings, and you have the center of gravity transverses the other axis of the aircraft. So through the center of gravity you have the rudder here, the vertical stabilizer. You can move, and also nose steering in the ground when you take off or landing. So you move both in the takeoff and landing until some airspeed. So you see the rudder deflected using the rudder pedals inside the cockpit. We can deflect the rudder like this, moving out the rudder pedals. So you see also we have the nose wheel steering, the forward nose wheel interconnected with the rudder pedals over here. So you see both sides are moving together. The captain and the first officer are also interconnected. So you move the rudder pedals left and right, and you make a yawing turn in the air or in the ground in takeoff and in landing. You can control the steering of the aircraft like this, left and right turns. You have also the nose wheel. It deflects left and right side from the tiller or from the rudder pedals, like 76 degrees either side, left and right. In takeoff up to an airspeed from 0 knots to like 45 knots. Then you have the rudder becomes aerodynamically effective at 45 knots. Then the nose wheel deflection would decrease from 76 to like 7.6 degrees either left and right side over here. So as you increase your airspeed, the deflection of the rudder of the nose wheel decreases, as the deflection of the rudder is more aerodynamically effective. So above 45 knots it decreases from 76 degrees left and right to 7.6 degrees left and right, and then above 18 nautical miles per hour or 144 kilometers an hour in takeoff, the nose wheel becomes it deflects to 0, so it's locked to 0 position. So you have only the rudder aerodynamically effective above 144 kilometers an hour. Or 18 knots in takeoff. So you see again the rudder pedals over here make left and right turns. The nose wheel steering 76 degrees up to 45 knots, then is 7.6 degrees, then to 80 knots decreases to 0. You have only the rudder. Rudder is aerodynamically effective above 45 knots. Also you have the nozzles, the tiller over here. So this is the yawing control. We have also one more axis here from wingtip to wingtip. It's the pitch axis. We can use the elevator or stabilizer trim also. So the elevator is the side stick up and down like this. As you can see, side stick up and down. You can climb and descend moving the elevator. It's the side stick in the Airbus. You move the elevator up and down like this. It's the yoke in the Boeing. You move the yoke up, back and forth like this. So you can climb and descend. It's the pitch axis of the aircraft. So we have one more axis over here to see. So we see the yawing axis. And we have over here also we have the nose wheel. We have from the front nose to the tail the longitudinal axis, this axis. So this is the side stick left and right is the longitudinal axis in the Airbus. In the Boeing is the control wheel left and right like this. You have also all flight controls together. And it's so side stick left and side stick right in the Airbus is yoke control wheel left and right like this. So this makes ailerons and spoilers in the Airbus, side stick left and right, or aileron, spoilers and flaperons in the Boeing. Using the Boeing right now, using the control wheel, make left and right turns, the pitch left and right, up and down side stick, and the rudder pedals. So you have all flight controls to move the aircraft, and also the flaps and the speed brakes are deflected like this. So this is climb, descend, make turns to the right, make turns to the left, or flight controls together. So I believe we have maybe one more minute over here. So you see we have one aircraft is coming for landing over here. We just spotted. It's Boeing 737. This is increasing in size. As it's approaching the runway over here, as you can see. Here we have it, Boeing 737-800 just landed. So we continue with the flight controls of the Boeing 787. Same like 737, 747, 757, 767, 777. So it's pretty much identical for Boeing aircraft. Maybe some Airbus also. You see side stick up and down. The elevator is the yoke in the Boeing. So we have the rudder also. So a few more things to see from the flight controls. So now we'll show you one more view of the flight controls of the Boeing 787 900 aircraft. Then I'm gonna show you how to use the flight plan as my computer. So I will set up the flight plan of the aircraft for this flight, and then I will make an engine start demonstration. So after the engine start demonstration, setting up the flight plan and see all the other systems that are left over, we're gonna make a complete flight from takeoff, climb, cruises, and approach and landing. So stay with me until the end part of the video to see the complete manual flight. I will fly the aircraft manually. So you see now I have this side stick, I have the setup again, the mouse pad, the computer, the keyboard. So I hope you like it. So I'm gonna use this side stick here to control the aircraft. So we climb and descend. So we can climb and we can descend like this. We can make turns to the right, turns to the left. So hope you like this view of the Boeing 787. Also the side stick that I have, the Lszh Extreme 3D is the same like in the Airbus aircraft side stick. So I have all the side controls over here. Hope you can see from the screen over here. Maybe change the view of the screen. So a little bit better. You can see the side stick over here. Deflection is proportional to the yoke deflection as I move the side stick. Also the captain and the first officer flight controls in the Boeing are moving together. The yoke, the control wheel and the rudder pedals, they are interconnected. Unless you have some failure or you need to apply force from either side to override either yoke. Also you can use in the Airbus you can use the side stick priority button over here, and now the autopilot disconnect button. So hope you like my Airbus side stick, and I use to control the flight controls of the Boeing aircraft. Also I can use the thrust levers over here. I can move all the thrust levers. I have this slider switch over here, so this moves the thrust levers accordingly, how much percent of thrust we need in takeoff, in landing, in flight. I apply manual thrust instead of having the auto throttle on. So we have all flight controls together. Horizontal trim stabilizer. I show you the horizontal trim stabilizer, what is it actually doing. So we fly the aircraft, make left right turns, climb, descent like in the Airbus. Hope you have better view right now. Horizontal trim stabilizer over here, thrust levers over here. So this is the side stick, the Lszh Extreme 3D, the cockpit, also the view. I will show you a little bit more of the outside again, how we can climb and we can descend using the elevator, the side stick or the control column in the Boeing, the yoke. Also horizontal trim stabilizer to balance the aircraft in flight. Rudder deflection over here. You can see rudder pedals left and right. Also ailerons left and right in the Airbus. Aileron spoilers, flaperons, ailerons and spoilers in the Boeing or the yoke. So this is all flight controls. We finished the flight controls right now. Lesson for tonight. We're going in the rest of the systems. So go for the rest of the systems of the Boeing 787. Hope you like all the side stick and the yoke of the Boeing 787, the rudder pedals, all flight controls all together, and the thrust, the engine power over here. Said. So now I will talk to you about a couple more things we need to know. The flight management computer. So I will show you now how to set up the flight management computer. I will need to put all the data of the aircraft for this flight, and include the empty weight plus the passenger plus the cargo plus the fuel on board, where the fuel is stored in the left and the right wing, in the center tank. So we have 30% in the left and the right wing tank, fuel tank, and also 10% in the center tank. And also we have all this makes out of the takeoff gross weight of the aircraft for this flight. So we have the flight management computer. Over here you can see I'm gonna set up input all the data one by one. So the flight management computer is gonna calculate the takeoff gross weight that I told you. So it's gonna calculate also the mean aerodynamic chord position of the forward wings, the Mach, that is 33% of the forward mean aerodynamic chord position of the forward wings, where the maximum aerodynamic lift occurs the forward wings. Also the center of pressure is moving back and forth, and also the angle of attack that we have the stall over the aircraft wings in flight is calculated, and also the horizontal trim stabilizer from takeoff. We're gonna be having 4.25 degrees of horizontal trim stabilizer, horizontal elevator actually. I'm gonna input also flaps 15 degrees, just like the flaps. Position that increase the surface area and the lift from the wings. We're gonna have also a couple more things we need. We're gonna select the runway for takeoff. So we have the Zurich International Airport, Lszh in Switzerland. I'm gonna use the runway 14. The runway length, the runway slope, the wind direction, the speed, the barometric pressure, the density of the air, and the temperature of the air. The flight management computer is gonna calculate all the data. For this, the takeoff speeds V1, V rotate, and V2. We're gonna use 100 or 99% of takeoff thrust power. We're gonna have a pitch attitude of 9 degrees or less for takeoff, and we're gonna be having the takeoff. We're gonna use the seats. The seats are the standard initial departure waypoints and fixes that include horizontal and vertical navigation features and altitude speed constraints for the initial climb and departure of the aircraft. We're going to be climbing to the cruise level 25, 26, 27, 28, 29, 30,000 feet above the sea level. We're going to be cruising there, fly through some waypoints, make a couple of turns, then we descend back to the airport, to the elevation of the airport like 7 or 6,000 feet above the sea level. We're going to be aligned with the runway. We have the SARS, the SAR terminal arrival waypoints and fixes for the long final, the short final, the terminal approach and landing of the aircraft in the airport. Runway we select, so we select the runway 14, Lszh in Switzerland. So the runway 14, we're going to be having the runway magnetic north pole heading 136 degrees for approach and landing. And also use the ILS localizer, the instrument landing system that I told you in the beginning of the flight. I'm going to be aligned with the horizontal localizer and vertical glide slope. We have the ILS system, the instrument landing system of its airport, and its runway has its unique radio frequency and antennas, and it's also to transmit radio frequency and line us with a localizer for horizontal alignment, and also with the glide slope for vertical flight path. We have the onboard antennas of the aircraft. We're going to set the ILS localizer frequency from the flight management computer automatically when we select the runway for landing. We're going to be having also flaps 25, 30 degrees extended for approach and landing, 160, 170 nautical miles per hour, airspeed like 250, 270 kilometers an hour for approach and landing. We're going to be having also landing gear extended, and also a pitch attitude like 9 degrees. Also now you can see here having the mouse pad to control. So we're going to have a complete flight, full manual flight. Also the flight management computer over here set. So you can see the flight management computer set from the mouse pad over here. So I will input from the keyboard. You can see also the screen. So I have identity, position, performance. Over here, takeoff, announce it, status, approach, navigation data, flight plan, loaded traffic control. So we start over here from this over here, control quadrant. So you can see again the mouse pad, the engines over here, the flaps, and the flight management computer over here from this display. So we go over here. So we're gonna set the identity of the aircraft is the Boeing 787-900 GNX engines, the air cycle. The position we're gonna set Lszh Zurich International Airport, Switzerland for IRS inertial reference system, longitude and latitude, the coordinates alignment. If we need from the IRS system, 0 fuel weight plus fuel on board, gross weight for takeoff, reserve, fuel cruising altitude, coast index, fuel freezing temperature, and the center of gravity. In flight, we're gonna use Lszh over here, airport in Switzerland, origin over here, destination. So we set also the runway 14 for approach and landing. Departure over here, select either runway 10, 14, 16, 28, 32. So we select runway 14, and the seats over here, the are arranging the departure. I'm gonna select the Zui to Alpha. So we have departures. Now we select arrivals. So we have 16, 28, 34, ILS 14, ILS 16, ILS 28, ILS 34, GLS 14, localizer 34, localizer 28. So we select ILS 14, Trans Amity, and Trans the Southern Terminal arrival over here. We select Negria 1 Alpha in the left side. So now we have the legs of the route. The route is displayed with blue color. It's not yet active. We see the first waypoint and the heading of the runway, 2 nautical miles. The altitude is gonna cruise Zui over here, have a discontinuity, climb to the cruise level in the Negria, descend Zurich 701, approach and landing. So we set over here 0 fuel weight plus fuel on board, gross weight for takeoff, the reserve fuel over here 5%, cruising altitude 25,300 feet over here, and the cost index 100%, fuel freezing temperature, gross weight, fuel on board 33,500, and 0 fuel weight 322.7, gross weight 356. So we have fuel freezing temperature, and we press execute over here. It will activate the route, the waypoints one by one. So we depart over here, fly to nautical miles 1, 3, 5, 6 is the Zui. As we climb over here, climb to the cruise level Negria, then we descend over here, make a right turn Zurich 701. So we have 26 nautical miles, 12, 6, 9 the airspeed, and also the altitude we have to fly through. TRA, we make a left turn here in the Ozone, approach and landing in the airport. This is the complete flight plan. So we use flaps 15 degrees, center of gravity over here automatically 4.35 degrees, V1 we rotate V2 for this gross weight. We have also the parts alternate VNAV progress, hold over waypoint, fix and navigation radio. We can tune ILS or VOR ADF. So we go back to the virtual cockpit very quickly. We need to start the engine, so I'll show you. We start the APU. We have left and right at 100 volts for 100 Hz frequency. The batteries, primary flight control computers in the auto, heading air data computers, flight control surfaces, FT door over here, town bar, power battery, and ram, and also passenger oxygen with the heat over here, rammer turbine. We have the hydraulics, left and right engine driving in the off position. You see what they display. The faults over here, so we turn back on, then to the auto position, set to the auto like this. We have also the recorders. We have the cargo fire, electronic engine control for the engines. The auto start, we can start the engines over here. If we turn on this to the start position, we have the fuel jettison, dump some fuel in flight and select the nozzles and how much to remain. Fuel booster pumps left and right, and center tanks, a crossfeed valve is solved, but if we turn it on, you can feed either engine with other pump or either tank and balance the fuel between the left and the right wing. This is what the crossfeed can do. Also we have the wing and engine RDIs over here, auto over here, and a couple more things. We have the cabin pressurization in the auto position. In the manual we use the outflow valves when climbing descent to pressurize and depressurize the cabin using the bleeder from the engines. Also the oxygen, so we have air conditioning here, the packs from the engines. I will show you now how to start the engines in a couple of seconds. Last thing to do here is to see the display and set up the autopilot panel. So the display of all the systems here before make the engine start demonstration, digital format of the system. You see the hydraulics, Over here, the APU is running, auxiliary power unit, oxygen and liquid cooling over here. The electric left and right controller 120 to 100 volts for 100 frequency, 120,000 kilovolts. The APU also is running. The load cell over here, main battery voltage and the APU battery voltage and numbers. Also the hydraulics, you can see where the hydraulic fluid goes over here at the flaps, like in instance primary demand, engine driving, electric driving, saddle valves. We have also the pressure 5100 psi left, right and center, and the quantity of the hydraulic fluid, the fuel left and right wing fuel tank 11,000, 11,000, 30%, 30%, 10% in the center, another 10,000, 33,300. Low and high pressure fuel valves open from the left and right engine, feed from the center or the wing tanks. The cross feed valve is off, but we turn it on, you can feed either engine with other pump or either tank. The APU is fed from the left wing using the DC motor. Also you can see we have the recirculation of the fuel from the wing tanks and the center tank in flight, because the fuel is gonna freeze. Also recirculate automatically from the farex the oil in the lubricant, so we have the recirculation of the fuel. You can see here the minimum fuel temperature minus 37 degrees in flight, below which will freeze, and the temperature of the fuel right now. So we have also the air pressurizer over here, the packs left and right packs. The doors are closed and the cabin can be pressurized. The gear, you can see the temperature of the brakes and the pressure of the tires. Flight controls over here, left and right flight controls, aileron, spoilers, the rudder, climb, descend, and the train stabilizer. FS display over here, so FS display, maintenance over here, digital maintenance also. We have the checklist over here, last thing to see before going to takeoff. Normal menu before start, after start, before takeoff, after takeoff, descent, approach, landing. So go back, navigation display, you can see the flight run. So we turn off both engines over here and restart them very quickly. So you see engines off over here, fuel control in the off position. You're gonna see the fuel starvation now from the engines. So if we look outside, the Boeing 787, you can see there is no fuel, the engines are shutting down now. Also the hydraulics, so we go here in the overhead panel very quickly and restart engine start, auto start in the on position, turns on the farex, the full authority digital electronic control computers that control the engines. Function, you can see dual channel redundancy, one channel phase, the auto takes over. So we have 20% only pressurizer right now to the engine. We can admit we have only pressurizer right now, so we can admit the fuel right now on. So we start the fuel flow. We have the auto start on when you turn on the fuel valve, so auto start above 29%. So this is the hydraulics also, auto start on. So above 57 we can go for takeoff in a couple of seconds. 61% we're gonna be having running engines, so engines are running. Flap set for takeoff over here, speed brakes up only. The heading altitude over here, vertical speed, you can see the vertical speed from the autopilot. I'm gonna set the altitude. Also altitude over here. Heading over here, set the heading 136 degrees. And airspeed over here. LNAV and VNAV if we need. We turn on the LNAV only. Parking brakes off, advance the thrust levers, we go for takeoff. So we take the air traffic control clearance from the airport tower, and we can go for takeoff. This is the runway. So we use the tiller to align with the center line over here. So the runway is open for us. We can taxi into the runway, align. We don't need to hold into the runway. So we align with the tiller here, as you can see. Advance the thrust levers to full takeoff power and go. So we have full takeoff. Pull the yoke down until 80 knots, or the size if you have an Airbus. So we have 90 knots. Pull up the yoke. 100 V1, 130, 140 V1. We rotate. Over here picks up like 9 degrees or less, as you can see. So this is the pitch up we need for takeoff, and we climb. As you can see, we have the positive rate of climb and departure over here. So landing gear is up right now as we climb. Pitch altitude is a little bit down. So we have here, you can see the terrain with red, green, yellow indication. So we are 1,700 feet above the ground level. The airspeed 205 knots right now. The engine's indication also, you can see the climb rate. So we are 2,300, 2,400 above the ground, 4,000 above the sea. The pitch altitude 20 degrees. The airspeed 195 knots. The stall speed here, you can see the trend lines also of the speed and the altitude. We climb with 6,000 feet per minute. The wind direction speed, the flight plan we created here. Also you can see we need to pitch down a little bit the aircraft like this. So you can see the terrain we are flying above. You can see the stall speed here with amber and red indication. So we can see we are just like 3,000 feet over here above the ground. 3,000-4,000 feet above the ground displayed. So outside, if we look outside, we have the view over here. The airport as we depart. We need to make the turn now. So make the turn to align with the flight plan here. And we have a few more minutes to go. So you can see we can leave the hands off from the side stick, no problem for an aircraft. Keeps turning. So make line with the flight plan here. Hope you like this beautiful view. The sky from the Switzerland over here, and the aircraft, the Boeing 787. To make an alignment over here, make a small turn. As you can see, have all the air data and the flight plan. So we align here like this, and we keep flying a bit more straight. So we're gonna be flying over So we have the cockpit here after takeoff of the Boeing 787. I'm gonna make a small manual flight. We can use also the autopilot if we need, but there's not enough time. So we keep climbing. As you can see, 159 nautical miles per hour, the airspeed, the stall speed here, the wind direction speed, the waypoint we have to cross through here, so we're gonna make another turn, the engine's indication here. Also the other side displays here the flight plan. So we have one more minute to start the turn for going back to the airport. So we make the turn here, align with the flight plan. So you can see we approach now the stall speed because we need to pitch down a little bit as we have closer to the stall speed. So we are also aligned with the flight plan here, what we need to fly through, the autopilot here, also indications, and the head-up display as we're climbing. So we're gonna be making the turn now. So here we are, we have the France in this side, the Galaxy, also the Germany, my homeland, Bayern Munich in front of you. So here is Germany, the lakes also, the Switzerland. So we're gonna start the turn now. We're going back to the airport and we're gonna be having a few more minutes. So you can see the turn. We leave the hands off, no problem. You can see also the turn, beautiful turn view. I'm gonna see the Germany, my homeland over here, Bayern Munich, the lakes. So this is beautiful Germany over here. We keep climbing, 21,000 feet. The aircraft also view. So we need to go inside. Last peak of turn over here. We use a little bit right rudder also as we turn to make a faster turn rate. So we have reached the stall point here. We need to pitch down also, or we can maneuver a little bit more. We're gonna skate through, and we are here. So we're gonna start going back into the airport, start the descent in a couple of minutes. So here we are, need to climb also. We're gonna be having the chemtrails in a couple of seconds. So here they are, the chemtrails, the frozen, beautiful frozen vapors. We overflying over here this beautiful area, as you can see. The star sign also. Need to level off, increase the airspeed now. So we have overflying the Switzerland, the Germany behind us, the Bayern Munich, and the France in this side, and the beautiful frozen vapors. can see. So we need to start the descent now. As you can see, idle thrust over here and start the descent. Flaps up also, and then the flaps, speed rate down. So we're gonna have a descent rate right now over here. And have like 6 more minutes for approach and landing. Use a little bit more airspeed, I guess. Increase the rate of descent. Over here you can see the airport just on the side. Idle thrust again. So we have this beautiful view of the cockpit one more time as we are descending. So we're gonna cross through these waypoints here. We are 14,000 feet. We are in a good position. We need to start the turn now to the airport. So we're gonna start turning like this as we descend, and use a little bit left rudder to make a steeper turn as descending. So this is the turn here, as you can see. So we have 3 more minutes left for the video to end as we take the turn over here. So we are almost aligned with the runway here. We are a little bit higher, as you can see, so we use landing gear down. Align also with the runway as we are descending. Also some flaps. And we have the runway here for alignment. Use left rudder over here. So we're going to be aligned here with the runway heading. As you can see, as we descend, we have some clouds also. Increase the rate of descent. Also use some thrust over here as we are turning. So here we are, we need to increase the rate of descent a little bit. So we're gonna have also the outside views with descent over here. We're gonna be having very nice view for touchdown. And we have a few more minutes of flying over here. So we use a little bit more thrust. We have some side wind over here. We need to align now with the side wind component. We almost reached the runway. 1 more minute to land. Add a little bit more airspeed over here. We have the side wind and wind gust. We have also the Lszh localizer over here. We need to follow the localizer for landing. So we need only to align with the horizontal over here. As you can see, a little bit rudder. You have some side wind, some wind gust over here. Increase also the airspeed a little bit as we descend, and increase the rate of descent a little bit. So we're gonna touch down in a couple of seconds. As you can see, idle thrust, align again with the runway. So we're gonna be having the flare here. So flare for touchdown over here. Beautiful flare, beautiful touchdown. Align with the rudder pedals over here, parking brakes, and idle thrust. So we have idle thrust reverse, full thrust reverse, and line with the rudder pedals. So we just made it, very beautiful. Over here, as you can see, touchdown and landing. So thrust reverse is not yet activated. Here we have it. So you can see all landing gear here is safe. Nose wheel, everything is safe. And now we're slowing down, as you can see. All wheels are safe. We can exit the runway.